Hello everyone, welcome back to another video. So today we are going to talk about templates, or also in simple words you can say pre-written code. Now this is a very common practice in competitive programming. Most of the competitive programmers have a specific template or pre-written code which they use. Now one of the example of that template can be my own template which I use. Uh, So this is my one of my latest submission for one of the question. Now as you can see, this this question was A due to A. Now this logic for this question is pretty easy. It's just a 4-line logic. But before that, there are this many lines of code. So these lines are basically pre-written. Now if you go to any of my submission, you will find this lines as common. So this many lines are common. So this is my pre-written code. So this is my template in simple words. Now why I use this template? Because it provides me convenience. Now what I will do is I will go through my template and try to explain each and every function, how it works, and try to explain why it provides me convenient and speed. And based on it, you can also build your own template, and I will also share you the template code to my code of my template. So let's just start with the template and what it does exactly. So we'll start with the entry point of C++, that is int main. Now ignore all the above lines and let's just start with int main. Now int main, in first there are 3 lines. So these are nothing but fast input output. So when you include these 3 lines, the speed of taking input output it's a little bit better. So when you are taking 10 raised to power 6 numbers as input, so these lines may be necessary in your code to uh, to speed up that input output. Now after that, you probably know that in most of questions there will be test cases, and the first line of the input would be number of test case. So what we'll do is we'll take the test case as input, and while t minus minus I'm calling a solve function. Now in solve function there is my logic for each test case. So something like, let's say uh, I have 2 test cases, and in each test case I'm taking n as an input. So what I'll do is, first of all, it takes 2 as input. So took 2 as input as number of test cases, and then called solve function twice and prints 2 integer 1 and 2. So this is a pretty standard way of dealing with test cases. Now after this, there are these additional lines, start and stop. Now this is nothing but to find the execution time of my program. So as you can see on the compiler logs, there is this is printed. So time equal to 1 ms. So this line here and time and that duration. Now it's in microseconds. So this is kind of useful for me when I'm trying to understand if the solution should, if my solution will pass system tests, or when I'm trying my solution on stress test, that means highest number of constraints, if my solution will not give me TLE or not. To check that, I used this, and it is pretty helpful while hacking solutions also. So this is the compilation and building time. So when I build this program, so it finds all the time. So this is printed by the build which I'm using, and this is printed by the program. So program only prints execution time, the run time of the uh, script or program. It's only now. So these are the main entry points: int main and then solve. So whatever logic of my question I have, I will write in solve function itself. Now let's just start with my template. First of all, uh, this header file including that standard template library bit slash std c++.h. Then I am also including another library which is chrono. Now chrono is used for this, so to find the time in execution time. I'm using that chrono library. Now STL has this namespace std. Similarly, chrono has chrono as namespace. So defining them. Then this is the code for policy based structure. Now what is policy based data structure? So a normal set, if you have idea about normal set is uh, to store all the unique elements. Now normal set won't support indexing. So if we want fourth element from the set, we can't get it in O of 1. We can obviously get it via using iterating over the set, but we cannot get it in O of 1 or log n. Now there is a policy based data structure which is ordered set, when where we can work with that sequence. Now, so to have that data structure, we need these lines. So poly policy based data structure. So PBDS means policy based data structure, and in that we mainly use ordered set only. So this is just to uh, declare an ordered set. So these are the lines. These are now commented here because I only use it when it is required. Then there are some aliases. So to improve my speed or convenience, so let's say if I want to declare a long integer as n, instead of calling it long n, I can just write lln. Similarly, if I have to uh, declare something like a long double x equal to 0.5, what I will do is I will just, instead of writing long double, I can just write ld. So this, instead of using the long forms of primitive data types, and I have declared a short form for that, and basically it is there to improve my speed and convenience. Now there are some constants which I am using. Now in most of in there would be a lot of questions in which you might want to declare a big number. Big number means, let's say if you want to take minimum of a vector, what you can do is uh, you can initialize the minimum variable. So I will just show you one example. So let's say you are given n integers. Now what you need is minimum of that. So what you will do is you will take input n integers from input and take its minimum with x. Now as mn is a big integer, on first comparison itself, it will all this condition will all x will always be less than mn, and the x value of x would go to mn. Now the other way of doing it is to take input x earlier, then initialize mn with x, and then take uh, n minus 1 inputs. This is also a way of doing it, but this is more convenient to declare a big number and use it whenever it is required. Now 4, this number is equal to 4 into 10 raised to power 18, which is just close to the maximum limit of long. Similarly, LD epsilon EPS is nothing but very small long double positive, uh, very small positive uh, double number. So in decimal. Now 1 e raised to power minus 9 means 1 by 10 raised to power 9. So this is a very small number, positive number. Now this is nothing but a mod value. Now in most of questions you will also be asked to print answer with mod something, with taking the total answer with mod. Now that mod can be either equal to this, or in some cases it will be equal to 1e9 plus 7. So whatever mod is required, you just change it here, and the whole code will use this variable, so you don't have to change it again and again. Now these are the constants. Then there are macros. Now macros are nothing but defining short forms for some long attributes. So first one is f, capital F for first. So when you are working with pairs, so there is a very data structure called as pairs. Now if you declare v, and we you need to access the first element of that pair, what you use is v dot first. Now if you don't want to use first, you will just make it v dot f, because we have defined it at f. Similarly, instead of using v dot second, what you can use v dot s. Similarly, there is I have declared all of x as begin x and end x. Now why is that? Because there are a lot of functions with vectors. You will need to pass this to iterators. So let me show you one example. So let's say you have a vector a. Now you need to sort a. Now for sorting it, what you what you will need is the begin and end iterator. So this is the syntax for sorting a vector. Now instead of writing this, what you can do is you can just write all of a. So all of a will go to here and process them as begin x comma end x. Similarly, if you have to reverse it, that is r begin r end, all r of x. Now similarly, if you have to declare a vector int, you write vi, and you have to declare a pair of int comma int, you write pi. So vector int a can be replaced with vi a, and pair int comma int can be replaced with pi a. So this both will work. Similarly, there is a function called as pushback for vectors. So instead of using push back, what we will do is I just use PB. Similarly, there is a make pair function. Now, make pair function is used for so let's say you have P. Now you want to initialize this pair. What you can do is you can declare two variables here, two integers here. So it will create the pair. I don't use it. I will just declare it as this to use curly braces and declare it as a pair. I don't use it that much, but this is one way of doing it. Then what I have declared is declare defined endl with backslash n. Now this is a very important concept that endl versus backslash n. Backslash n is a lot faster than endl, which is uh, very important. I'm I made this mistake in my first ICPC preliminary contest. I solved the question, but I was using endl and I kept getting TLE. So always use backslash n instead of endl. Now I have a habit of using endl. So what I did here is I replaced endl with backslash n. So whenever I'm using endl, it will point to backslash n, not endl. And writing endl is faster for me because I have to write this backslash and then n. So instead of that, I can just type endl. Now there is this also. I don't use this also. So this is just to iterate over the for loop. Now this I don't have practice for this, but I had in this template if for any use in future, but I don't use it right now. And this is not necessary. You can just write a normal for loop. Now these are about the some definitions of functions, definition of macros, aliases, constants. After that, these are all the this is all the modular arithmetic. Now this was not there in when initially when I created the template, but later I struggled on a problem for which was a problem B in code forces due to and in which there was modular inverse involved. Now if you don't know modular inverse, I will suggest you go through modular arithmetic, and because this is a very common question, most of the, in I think a lot of questions you will be asked to print answer with modulus 1 9 plus 7 or this number. So and you will have to use the concepts of modular arithmetic, and especially you will need to study inverse, modular inverse. So at that time I didn't have idea about inverse. I tried to implement it on my own, but I couldn't do it. So what I did after that is copy pasted all these functions in my template. Now this is how I improved my template. Whenever I struggle with something, I will add that in my template itself. So this is the thing but modular arithmetic, and all these functions are using this mod. So there is this mod and this mod. I generally use this. I don't use this because I mainly use these functions. I don't write this modular formula every time. I will just use these functions. Now there is this sieve function. So this is just to pre-compute. Mainly this is used for pre-computation, but this function will return all the prime numbers till n in a vector. So this is a huge logic. You can go through this on CP algorithms. The search sieve of Eratosthenes and SIP algorithms, you will see the algorithm and find the use of it. Now this is interesting. So I will show you one example of it. So let me just take one test case, three inputs, 1, 2, 3. Now ideal way is you declare a vector of size n, and then what you do is you iterate over n and take input as Cn of A of I. Now what this template does is, so let me show you. Let me print A of 0. So it prints 1. uh, so basically prints all. Let me just print all of them. So this is the standard way of taking a vector int as input. Now what I have done here is I have used this template functionality of C++, and what I'm doing is I have declared an operator overloading function which will do something like this. So what I'm doing is I'm directly taking input as vector itself. Now this is not a standard syntax of C++, but what I have done is I have overloaded this operator, and so I basically told C++ that whenever this operator is used and there is a vector in that, there is a vector which is taking it as input, I've uh, just replicate this functionality. Now what this is just iterating over a vector and taking it as an input. Now if you try run this code, it will still work. So it is printing. Let me just make some changes. So it takes the whole vector as input and prints it. Similarly, for input, I also did the same thing for output. We cannot print them directly. This is if you try to do it directly, it will give syntax error. So using this operator overloading, I am able to do it. So you can also do it with pairs, everything. Just using this has some conditions that this size of vector should be fixed. If you declare something like this, then it will take 0 uh, inputs. So that's it will only take num numbers of it will only take inputs equal to the size of vector. So you will have to fix the vector size before taking its input. Now after that, it starts with some mathematical functions. I don't use them, but they are in my function. So first is this GCD. Now this also in C++ also has an inbuilt function like this underscore underscore GCD of a comma b. So I use the inbuilt function itself. I don't use this, but there it is in my template. Similarly, this is a GCD extended. This helps me to find two multiples which forms the GCD. You can go through this function. if you want to understand what it does. Then there is this LCM. Now LCM's formula is LCM would be equal to A into B divided by GCD of A comma B. So this is the formula of LCM, and I don't think there is an inbuilt function for LCM. That's why I declared this. This is based on the GCD which is here declared here. Then there is binary power or modular power. So I have created a video recently on binary exponentiation. So this is the binary power. Similarly, there is modular inverse. Now, modular inverse has two logics. One is this inverse, and another one is uh, this inverse. So both has some different logic. If you go through modular inverse, there you will find two methods of solving a modular inverse. Both of them are implemented here. Now this is to print a random integer from L to R, to get a random integer from L to R. Now this is useful for me when I'm generating test cases. So when I try to hack some solution, what I will do is I will use this function for randomization in my test case. Now these are pretty important functions I use in bit manipulation to draw some observations. So first function is bin to decimal, so binary to decimal. So I will give input as a 64 length binary string, and it will convert it to a decimal. Similarly, there is decimal to binary. So I will give input as a decimal integer number, and what it will do is it will give me a 64 length binary string. So first is binary to decimal, second is decimal to binary. Now there is this AND operator. Now this is a pretty specific type of operation. I think I used in one of I I added this when I was trying to solve one question. So this is a addition which did in my original template. Then this is factorial. Just find factorial of n. Barely use it because whenever there is factorial, it is better to pre-compute those factorials instead of calling this factorial function. Now this is the LCM. Now this LCM is based on the inbuilt GCD function, not the function which I have declared. Now this is a power without mod, so just 2 raised to power 3 without mod. Now this is a recursive type of mod. Now this I added for I just need to find power without mod, so I have added this. Then this class compare is I think for uh, a sort operation for queues and sets. So custom sort for queue priority queues, sets. So there are you can change the implementation of set by passing a custom sorter, custom compare logic. So for that you need a class. So this is the way to do it for sets and priority queue. But while sorting you don't need class, you just need a function. That's it. Now this is just a function which I have used, I think. So this is question related logic, not template. Finally, this is the binary exponentiation a raised to power p mod m. There might be multiple repetitions, but each of them is a little bit different. This is an NCR, so computronics problem. You need to find NCR for, and what I'm passing here is a factorial a vector where factorials are pre-computed. Now, so if this is the NCR function, so take factor of n, divide by it with f of r, divided by f of n minus r. Now, if you are to just create it with replace NCR with NPR, you will just you can comment just this line and it gets converted to an NPR function. Then there is this mySQRT function. Now C++ has SQRT function, that SQRT and SQRTL, but it has some precision errors. So it is better to use a custom SQRT function, and you will never need to find a exact square root of any number. What you will need is floor of its square. So for 25 it would be 5, for 26 it would be 5 also, because 26 square root would be 5.1, something like that, and you will need its floor. So you can calculate it using binary search. Then there is this compare sorter. So this will be used when you are sorting a vector based on your specific logic, or when there are so this is nothing but compare when sorting, when you are trying to sort a pair, vector of pair based on its second value. So that type of custom logic. And this is just another uh, check function, I think. This is again based on a question, uh, not specific to my template. So this is overall template. I think most of them I use. There are also some codes which I don't use, but removing them is also not a great idea because I might need them in some time. So I just kept it as it is. Now you can also build something like this on your own. Now how can you build it? Start with simple templates. So just something like this and this macros. Then you will come across some questions where you will find that you are difficult in while implementing modular arithmetic. Let's say my example, I failed when I was implementing modular arithmetic. So what I did here is copy pasted some functions from someone else submission after the contest, and then I saw how he is using it, and then I did it myself. So this is how your template should grow based on questions, and whichever topics you find difficult, learn from them and add it to a template if it is convenient. Now this template, I started using this template by watching someone else template. I'm not sure. Uh, I copied I copied this template from Codemaster CPP. So there would be some common things here, but I copied some initial things and after that I modified it again. So you can also do it. So that's why I'm sharing this my CP templates link. So it's on my GitHub. I will ping this. I will add this link in my in this video's description. You can go through it. Take some take the code which you require, and this is to give you more convenient while problem solving, not to increase the complexity of your code. If it is convenient, then only add it to your template. If it is not, then don't add it, because it will just im- increase your speed of coding instead of decreasing. Increase your time instead of decreasing it. So if it is convenient, then only add it. Now also there is a debate on why should uh, this becomes a habit while you go into software engineering, that you always use macros and this becomes This can become your habit, and im- uh, your code quality might decrease. So what I do for that is, so for code forces and code shift, I use template for add coder also. So for strict competitive programming, I use templates. But for lead code, what I will try is not to use any kind of template. I write most basic code for lead code. So I have practice for both normal coding and this template based coding. So you can also replicate this type of strategy. I guess that's it from my side. All the links will be there in the description. And also, we hit 2000 subscribers. So, thank you for that also. And thanks for watching.